All right, we have the 3.7a guided notes. Even though it says 3.6a there, that was a typo by me. I apologize. These are 3.7a guided notes. Now, recall that the absolute value, we've already discussed this, but the absolute value is the distance away from 0 on a number line. Now, there's two ways of thinking about that. We could actually go off and put ourselves a number line out there and see and count distance. So let's go ahead and get that number line out and show here we have a number line. And let's put 0 on our number line. So we could think about this as distance away from 0 on a number line. Or we can say that whatever the value inside those bars is, it'll always be positive. So absolute value is always positive. Well, that's true in a sense that distance is always positive, right? We've never gone in the car. We've never gotten in a car and drive, negative 12 miles to grandma's house. That's never once happened. We got a call here. Hello?
Sunday. Is that going to be a problem? I forgot I got to go to KU for the open house.
On Saturday?
Yeah, it's on the 4th.
Okay.
That's all about it. But if you're not busy Sunday, I'd love to get with you sometime afternoon.
Chiefs. We got to work around the Chiefs game, but it'll be after the Chiefs game.
Okay.
Cool, man. I'll see you Sunday.
All right.
Have a good week. All right. So, note, absolute value is the distance away from 0 on a number line, and absolute value again always going to be positive. So the absolute value of 6, 1, 2, 3, 4, 5, 6. Right, that's 6 away from 0 on a number line, so that's going to be 6. Right. So here, negative 21. Here's negative 21. That looks like negative 4, doesn't it? Let's change that up. Negative 21. Negative 21 is exactly 21 units away from 0 on a number line. So negative 21 becomes 21. 0.0125, that's this one right here. And that is exactly 0.0125 units away from 0 on a number line. Alright, what about negative 126? That's way out here. Negative 126. Well, that is 126 units away from 0 on a number line. So just note that anything inside of here can be positive or negative, but the output will always be positive. So even though it's a negative 21 inside, it produces 21 on the outside. Even though it's negative 126 on the inside of these absolute value bars, it's a positive 126 units away from 0 on a number line. And remember, distance away from 0 on a number line. So here the big idea with these is that we have to we need to isolate the absolute value bars first whenever we solve. Well, here in this example, we have the absolute value of x equals 7. So what are my two possibilities inside here? Well, x can equal 7, right? Because the absolute value of 7 is 7. And x can equal negative 7. Because the negative 7, the absolute value of negative 7, excuse me, is 7. So it works that x equals the positive and the negative version. So the inside stuff can equal the positive and the negative version of that. And my absolute value was isolated first. Notice it's only the thing on the left-hand side is an absolute value bar, right? The only thing on the left-hand side of this equation is an absolute value bar. So here, this 2x then can equal 8. So 2x, all the stuff on the inside can equal 8. Or 2x can equal negative 8. Because those are the two things that go on the inside of that to produce 8. So to solve this one out, we divide both sides by 2. Here, we divide by 2, and x equals 4. Now here I divide by 2, and divide by 2. X equals negative 4. Okay, so now we know that these absolute values are then going to break into two different equations. Well, let's see what happens here. All right, so here, again, we want to isolate the absolute value bars first. That's the big idea here. Now, my absolute value bars are not isolated with this one. I need to get rid of this 4 before I do anything. So here, I want to subtract both sides by, I'm going to subtract 4 from both sides, excuse me, subtract 4 from both sides. So now I have the absolute value of x minus 2 equals 12 minus 4 is 8. So now, all this stuff is equal to 8, and all this stuff is equal to negative 8. So I have x minus 2 equals 8, or x minus 2 equals negative 8. And now I want to solve each one. And so here I want to add 2 to both sides. So x equals 10. I want to add 2 to both sides. So x equals negative 6. And these are my two answers here. Alright, so here we need to isolate our absolute value bars first. I want to isolate these. So I want to add 3 to both sides. So now I get 2 times the absolute value of x equals 10. Now here, I have to get, again, I need to isolate my absolute value bars. I'm not isolated yet, so I need to divide both sides by 2. And divide both sides by 2. And now I get the absolute value of x equals 5. So my absolute, that doesn't look great. I'm going to isolate the absolute value bars first. So the absolute value of x is 5. So that means that x equals x, not y, x equals 5, and x equals negative 5. Those are my two options here for this one. So when it comes to solving absolute value equations, we want to make sure that we isolate the absolute value first, and then we break it into two scenarios. Okay, I want to do one more of these here, and I'm going to make this one up. So I have the absolute value of x plus 13 plus 6 equals 2. Now for this one, I want to see this on the back side of your page. I'm going to ask to see it, otherwise your notes aren't complete. So if I subtract 6 from both sides, again, isolating the absolute value first, right? The key idea, the big idea, we want to isolate the absolute value first. So I take 6 away from both sides, and here I get the absolute value of x plus 13 equals negative 4. Now wait a second. Absolute value is the distance away from 0. In other words, the absolute value is always going to be positive. But here in this example that I just gave us, the absolute value of this business is negative. That's weird. So anytime we run into a situation where the absolute value equals something that's negative, there are no solutions. No solutions. No solutions. So the absolute value, when it's equal to a negative, there's no way that'll ever happen. Something to think about. I really want you guys to thinking about that. So the homework we're going to do on a page 211. We're going to do problems number. I'm going to do problems 9 through 31 odds. So hopefully we had enough examples to kind of get ourselves where we need to be. But 9 through 31 odd, should be able to do all of those. Yeah, we should have the ability to handle every single one of those at this point. Again, we're going to do a lot of this in class and work on it in class. So if you have questions, make sure you bring them to class. Other than that, I hope you have a great day.